In the humid coastal air of Sriharikota, a colossal white monument stands poised between the earth and the heavens. It is a machine born of dreams, forged in fire, and assembled with the precision of a watchmaker on a gargantuan scale. This is not merely a rocket, it is a declaration, a testament to a nation's journey from navigating by the stars to reaching for them with its own hands. Steam billows from its base, a phantom cloud shrouding the immense power coiled within its metallic sinews. The final seconds of the countdown are not just numbers, they are a heartbeat, a rhythmic pulse felt by millions across a subcontinent. Each tick is a culmination of decades of struggle, of silent toil in laboratories and workshops, of failures that taught more than successes ever could. This behemoth known as the Launch Vehicle Mark III, or LVM3, waits for its moment of destiny. It carries within its payload fairing the heaviest burden ever entrusted to an Indian launch vehicle. A constellation of satellites, a web of future connectivity for the entire globe, is nestled at its apex, ready for a voyage into the void. The world watches for this is more than a single nation's triumph. It is a critical maneuver in a new, frantic, and breathtakingly ambitious global space race. A frenzy of fire and ambition that is reshaping our access to the cosmos itself. Ignition. A torrent of incandescent energy erupts from the base, a man-made sunrise that momentarily vanquishes the night. Sound, a physical force, a tangible pressure wave, rolls across the landscape, a thunderous announcement of departure. The ground trembles not in fear, but in reverence for the sheer power being unleashed. This gentle giant, this three-stage titan, begins its ascent slowly, deliberately, as if shrugging off the immense weight of Earth's gravity with disdainful ease. The two solid rocket boosters, the S-200S, burn with ferocious intensity, each one a marvel of solid propulsion, providing the initial overwhelming thrust needed to lift nearly 640 tons of machinery off the ground. Imagine two of the largest solid fuel motors in the world, strapped to the side of a central core firing in perfect synchrony. They are the brute force of this operation, the initial explosive release of energy that begins this celestial journey. For just over 2 minutes, they are the roaring soul of the machine, painting a brilliant plume against the sky. Then, having expended their fury, they fall away, their task complete, two massive javelins cast back towards the ocean. Now the core liquid stage, the L-110, takes center stage. Its twin Vikas engines, a legacy of relentless Indian engineering, continue the relentless push against gravity. This is the second act of our drama, a sustained, controlled burn that carries the vehicle through the thinner wisps of the upper atmosphere. The physics at play here are a ballet of extremes. Combustion of hypergolic propellants, chemicals that ignite spontaneously on contact, generates a steady, powerful exhaust. This stage is the marathon runner taking over from the sprinters of the solid boosters, ensuring the vehicle gains the necessary altitude and velocity. It is a testament to the mastery of controlled chemical reactions, a fire held in check and directed with astonishing precision. The journey upwards is a violent yet exquisitely calculated affair. The LVM3 sheds mass as it burns fuel, becoming lighter, accelerating faster, a creature transforming itself as it climbs towards the vacuum. Finally, the L-110 also completes its burn and separates a spent shell, returning to the planet that birthed it. The final and perhaps most crucial part of the climb now begins. All hopes rest on the C-25, the cryogenic upper stage. This is the pinnacle of India's rocketry achievement, a technology so complex, so difficult to master, that its possession grants entry into an exclusive club of spacefaring nations. Imagine attempting to manage liquids colder than the deepest Antarctic winter, at temperatures where air itself becomes a liquid. Liquid hydrogen, the fuel, must be kept at a mind-numbing -253 degrees Celsius. Liquid oxygen, the oxidizer, resides at a comparatively balmy -183 degrees Celsius. These supercooled high-energy propellants are the secret to a rocket stage's efficiency, providing a massive specific impulse, the rocket equivalent of getting more miles per gallon. But containing and pumping these substances is an engineering nightmare. Metals become brittle, seals can fail in an instant, and the slightest leak can lead to catastrophic failure. India's journey to this cryogenic mastery was long and arduous. It was a path paved with international sanctions and technology denial regimes, a challenge that forced its scientists and engineers to innovate from first principles. The CE-20 engine humming to life in the blackness of space is not just a piece of hardware, it is the embodiment of a nation's scientific self-reliance, a declaration of independence written in frozen fire. This cryogenic stage will perform the final delicate maneuvers, a cosmic surgeon placing its precious cargo into the precise orbital slot required. It will fire once to enter a parking orbit, coasting silently across continents, and then fire again at the perfect moment to circularize that orbit, releasing the satellites one by one like a celestial gardener planting seeds in the heavens. The payload for this historic flight consists of 3 6 satellites for the OneWeb constellation. This is not just cargo, it is a piece of a revolutionary global puzzle. OneWeb, a company based in the United Kingdom, is building a massive network of over 600 satellites in low Earth orbit designed to provide high-speed, low-latency internet to every corner of the globe. Think of it as weaving a digital blanket around the planet. For centuries, we have been bound by terrestrial infrastructure. Cables laid across ocean floors, fiber optic lines buried beneath our cities. These constellations propose a new paradigm. Internet access that is not dependent on geography, that can reach a remote Himalayan village, a research station in Antarctica, or a ship in the middle of the Pacific with equal ease. To understand the significance, picture a traditional communications satellite. It typically resides in a geostationary orbit over 35000 kilometers away. It appears to hang motionless in the sky, which is excellent for broadcasting. But that immense distance introduces a significant time delay or latency, which is problematic for real-time applications like video conferencing or online gaming. Low Earth orbit satellites, or LEOs, fly much closer, typically between 500 and 1200 kilometers up. This proximity drastically reduces latency, making the connection feel instantaneous. However, because they are so close, they move across the sky very quickly. To provide continuous coverage to a single spot on the ground, you need a vast interconnected network of them, a celestial relay team. As one satellite moves out of range, another seamlessly takes over. The LVM-3's task on this mission was to act as a cosmic deployment bus for this intricate system. The total weight of these 36 satellites was nearly 6 metric tons, a payload mass that shattered all previous Indian records. It demonstrated that the LVM-3 was not just a vehicle for national missions, but a powerful, reliable, and commercially viable player on the world stage. This specific launch carries a heavy geopolitical subtext. OneWeb had originally contracted with Russia's Roscosmos to launch its constellation aboard the venerable Soyuz rocket. However, following the geopolitical shifts and sanctions stemming from the conflict in Ukraine, that partnership was abruptly severed. OneWeb was left with a constellation of satellites on the ground and no ride to orbit. This created a sudden massive void in the global launch market, and into that void stepped India's LVM-3. This was not merely a commercial transaction, it was a strategic realignment of the celestial chessboard. ISRO, the Indian Space Research Organization, proved that it could offer a world-class heavy lift service that was both technologically capable and geopolitically dependable. It was a moment of arrival, a signal that a new power broker had entered the high-stakes game of orbital access. The success of this mission resonated far beyond the technical achievement. It was a demonstration of agility in a rapidly changing world, a testament to India's emergence as a credible alternative in the multi-billion-dollar global launch industry. To truly appreciate this moment, we must journey back in time to the very origins of India's romance with the cosmos. Long before rockets pierced the sky, ancient Indian astronomers like Aryabhata and Brahmagupta were mapping the heavens with remarkable accuracy. They calculated the length of the year, understood the causes of eclipses, and even theorized about the concept of gravity. This ancient legacy of scientific inquiry laid a philosophical foundation, a cultural predisposition towards looking up and wondering. But the leap from celestial observation to celestial exploration required a visionary. That visionary was Dr. Vikram Sarabhai, the father of the Indian space program. In the 1,000 960 seconds, in a newly independent nation grappling with immense poverty and developmental challenges, Sarabhai argued passionately that India must not be left behind in the dawning space age. His vision was not about competing in a Cold War race to the moon. It was fundamentally about using space technology for the betterment of his people. Satellites for weather forecasting to protect farmers and fishermen. Satellites for communication to connect a vast and diverse nation. Satellites for remote sensing to manage natural resources. The beginnings were impossibly humble. The first sounding rockets were launched from a repurposed church in a small fishing village in Kerala. Rocket parts were famously transported to the launch pad on the back of a bicycle and in bullock carts. It is a story of ingenuity born from scarcity of making the impossible happen with limited resources but unlimited determination. From those modest origins, ISRO grew step by patient step. It developed its own satellite launch vehicles, the SLV and ASLV, then the much more powerful Polar Satellite Launch Vehicle, the PSLV. The PSLV became the workhorse of the Indian space program, a vehicle so reliable it earned the moniker of the trusted horse, launching hundreds of satellites for both Indian and international customers. But ISRO knew that to achieve true self-reliance, to launch its heaviest communication satellites, and one day send its own astronauts into orbit, it needed a much bigger chariot. It needed a heavy-lift vehicle. This quest led to the development of the Geosynchronous Satellite Launch Vehicle, or GSLV program, and ultimately to its most powerful evolution, the LVM3. The LVM3, originally called the GSLV Mark III, was a clean-sheet design. It was engineered to be simpler, more robust, and significantly more powerful than its predecessors. Its development journey was a saga of its own, spanning over a decade and a half. It was a marathon of design, testing, and overcoming the immense challenges of cryogenic propulsion. The successful launch of the OneWeb satellites was not just a single event, it was the graduation ceremony for this magnificent machine. It proved its mettle not in a developmental flight, but in a high-stakes commercial mission with the world watching. From a bicycle to a behemoth capable of placing 6 tons in orbit, the journey of ISRO encapsulates a nation's scientific coming of age. The success of the LVM3 is a powerful chapter in a much larger story, the global rocket frenzy. For the first half-century of the space age, access to orbit was the exclusive domain of a few superpowers. Launch vehicles were built and operated by government agencies. Their costs were astronomical, and their launch cadences were infrequent. The entire system was slow, bureaucratic, and prohibitively expensive for most commercial or scientific ventures. Then, in the early 21st century, a revolution began to simmer. This upheaval was driven by a new breed of private companies led by visionary and often eccentric billionaires, who saw space not just as a frontier for national prestige, but as a new economic arena. The most disruptive of these forces has undoubtedly been SpaceX. With its Falcon 9 rocket, SpaceX didn't just build another launch vehicle, it fundamentally rewrote the economic equation of getting to space. The key innovation was reusability. For decades, rockets were treated as disposable. Incredibly complex and expensive machines worth hundreds of millions of dollars were used once and then discarded into the ocean. It was like flying a brand new Boeing 747 from New York to London and then scrapping the plane upon arrival. SpaceX pursued the seemingly impossible goal of landing and reusing the first stage of its rocket. After numerous spectacular failures, they succeeded. Today, the sight of a Falcon 9 booster returning from the edge of space to land gracefully on a drone ship at sea has become almost routine. This reusability has dramatically slashed the cost of launch, opening the floodgates for a torrent of new satellite constellations, scientific missions, and commercial activities. SpaceX's Starlink constellation, a direct competitor to OneWeb, has already launched thousands of satellites, demonstrating the power of a vertically integrated approach, where the same company builds the satellites and the rockets that launch them. This has created immense pressure on every other launch provider in the world. The old model of expensive, expendable rockets is no longer sustainable. Everyone must adapt or risk becoming obsolete. This new reality has ignited a global frenzy of innovation and competition. In the United States, alongside SpaceX, you have Blue Origin, founded by Jeff Bezos, which is developing its own massive reusable heavy-lift rocket called New Glenn. You have a host of smaller companies like Rocket Lab, which specialize in launching smaller satellites with their Electron rocket and are even pioneering their own form of reusability. In Europe, Arianespace, the long-standing leader in the commercial launch market, is racing to field its next-generation Ariane 6 rocket to compete on cost. China, a formidable space power, is rapidly expanding its launch capabilities, with its Long March family of rockets, and state-backed private companies are emerging to mirror the American model. Russia, whose Soyuz rocket was the backbone of human spaceflight for a decade, is now facing increasing isolation and a loss of its commercial market share. And into this crowded, chaotic, and fiercely competitive arena, India's LVM3 has firmly planted its flag. Its strength lies not in reusability, at least not yet, but in its proven reliability and its significantly lower cost compared to the traditional expendable rockets of Europe or the United States. It occupies a crucial niche in the market, a dependable heavy lifter available at a competitive price point backed by a sovereign government that is seen as a stable international partner. This frenzy is not just about launching internet satellites, it is the essential precursor to the next era of human activity in space. Cheaper, more frequent access to orbit is the enabling technology for everything else. It makes building new space stations like NASA's Lunar Gateway or India's proposed Bharatiya Antariksh Station economically feasible. It is what will allow for the construction of lunar bases and the eventual human exploration of Mars. It fuels the dreams of asteroid mining, space-based solar power, and a future where humanity's economic and cultural sphere extends far beyond the confines of Earth. We are living through the most transformative period in space exploration since the Apollo era. It is a transition from an age of government-led exploration to an age of commercial development and settlement. The rockets rising from launch pads in Florida, Kazakhstan, French Guiana, and now with renewed vigor from Sriharikota are the engines of that transformation. What does the future hold for India's Titan, the LVM3? Its role is set to become even more central to the nation's ambitions. The LVM3 is the designated launch vehicle for Gaganyaan, India's first human spaceflight mission. This will be the rocket that carries Indian astronauts or Vyomanauts into orbit, making India only the fourth country in the world to possess an indigenous human spaceflight capability. The human rating process for a launch vehicle is extraordinarily demanding. Every system must be triply redundant, every component tested to its breaking point. The safety of the crew is paramount. The LVM3's flawless performance record is the foundation upon which this monumental undertaking is being built. Beyond Gaganyaan, the LVM3 is the key to India's interplanetary aspirations. It will launch the next generation of lunar exploration missions, including a proposed sample return mission. It is the only vehicle in India's inventory powerful enough to send large, sophisticated probes to Mars and even Venus. A mission to study the Shukrayaan orbiter to Venus is already in the works, and the LVM3 is its designated ride. There is even talk of evolving the LVM3, perhaps, by adding a more powerful semi-cryogenic stage to further boost its payload capacity. This would allow it to launch even heavier communication satellites directly into geostationary orbit, or to assemble modules for India's future space station in orbit. The rocket that began its life as the GSLV Mark III has matured into a versatile and powerful platform, a cornerstone of India's access to space for decades to come. But this new space age, this rocket frenzy, is not without its perils and profound questions. The proliferation of massive satellite constellations, while promising global connectivity, is also cluttering low Earth orbit. The risk of collisions grows with every launch. A single impact could generate a cloud of debris, which in turn could trigger a chain reaction of further collisions, a scenario known as the Kessler syndrome. This could render certain orbital altitudes unusable for generations, a celestial minefield of our own making. Astronomers are also raising alarms. The bright streaks of thousands of new satellites are increasingly polluting the night sky, interfering with the sensitive observations of ground-based telescopes that seek to unravel the universe's deepest mysteries. There are questions of space traffic management, of orbital debris mitigation, and of the weaponization of space. As more nations and corporations become dependent on space-based assets, these assets also become potential targets in future conflicts. The heavens, once a symbol of peace and universal wonder, are becoming another domain for geopolitical competition and military posturing, and there are philosophical quandaries as well. As we stand on the cusp of becoming a multiplanetary species, what responsibilities do we carry with us? How do we ensure that the expansion into the solar system is done sustainably, inclusively, and for the benefit of all humanity, not just a select few? The rockets are merely tools. The choices about how we use them, the future we build with them, still rest in our hands. They can be instruments of unity and discovery, or vectors of conflict and division. Let us return to that launch pad in Sriharikota. The LVM3 climbing on a pillar of controlled fire is more than a sum of its parts. It is not just turbopumps, fuel tanks, and guidance computers. It is the physical manifestation of a nation's will. It is the embodiment of Vikram Sarabhai's seemingly audacious dream, a dream nurtured across generations of scientists, engineers, and technicians. It represents a mastery of some of the most complex technologies ever conceived by humankind. The successful deployment of the OneWeb satellites was a flawless technical performance, a commercial victory, and a strategic masterstroke. It announced to the world that India is not just a participant in the new space race, but a formidable competitor, a reliable partner, and a nation with ambitions that stretch to the moon, Mars, and beyond. The global rocket frenzy is a story of fire, of fierce competition, and of the unrelenting human drive to push boundaries. It is a chaotic and exhilarating dance of innovation, capital, and national pride. In this grand cosmic ballet, India's LVM3 is no longer waiting in the wings. It has taken its place on the center stage, a powerful and graceful performer ready for its next act. The thunder of its ascent is the sound of a new chapter being written in the story of our journey to the stars, a story that is just beginning. The light from its engines fades as it disappears into the upper atmosphere, but the impact of its journey will be felt around the world for years to come. It is a reminder that from the humblest of beginnings, with enough courage, enough perseverance, and a steadfast gaze fixed on the heavens, anything is possible. The sky is not the limit, it is only the beginning.